Right? So, what is it though? It's where it crosses the what? X or Y axis. Everybody understand that? From a graph, that's very easy to see. Do y'all understand that? I'm assuming everybody can find X and Y-intercepts from a graph. Because you're just looking for what? How do you find the X-intercept? You look for where it crosses the X-axis. How do you find a Y-intercept? You look for where it crosses the... Everybody understand that, right? We're going to look at this graph first. Alright? And you just told me this. When we talk about intercepts, the X-intercept is the point where it crosses what axis? The X-intercept is where it crosses what axis? So this is the point where it crosses the X-axis, right? What's special about that point? What's special about the point where it crosses the X-axis? Has a nice feature. Anybody can help me out with that? Come on, you guys know this. What's special about the point where it crosses the X-axis? Besides being an X-intercept, what do you know about that point? What do you know about the Y value at that point?
0.
It's 0. So I don't want to hear there, right? So here, where it crosses the Y-axis, where it crosses the X-axis at, the Y value is equal to 0. And in the next, and in a Y-intercept, what's special about that point? What's special about the Y-intercept is where it crosses the Y-axis, right? What's the X value at that point? 0. So essentially what you're looking at now is this. When you look at the X-intercept, you're looking for, you want to set the function equal to 0. Because when the function is equal to 0, you're going to actually find, though, you're telling me that the Y value for this function is 0. We know the Y value, if the Y value equals 0, that means we're finding X-intercepts. For the Y-intercept, the X value is 0, so that means you're evaluating the function at f of 0. Realize there's a distinction there. One says set the function equal to 0, the other says that the X values are all 0, right? I see that? Both of these, the intercepts, intercepts are always going to be written as points. They're always points. You understand that? Intercepts will always be points. When I ask you for an intercept, you're going to give me an X and Y coordinate. If I ask you for the X-intercept, you're going to give me the X value. And what's the Y value going to be? What's the Y value? Say it louder. Thank you. That's how you write the X-intercept, as a point. And actually for the Y-intercept, you're going to give me the, what's the X value at the Y-intercept? And the Y coordinate. We understand that? Now, let's look at this graph first. From the graph, it's easy to see the X-intercepts, right? We're looking for where it crosses the X-axis. Where does this graph cross the X-axis at? Well, it crosses it here and here. So when I ask you for the X-intercept here, what is the X-intercept of this graph? One X-intercept would be what? -2, 0, as a point, remember? What's the other X-intercept? 6, 0. If actually for the Y-intercept, well, where does it cross the Y-axis at? Down here at, what's the Y-intercept? How do you write that as a point? 0, -12. Visually, it's easy to see the X and Y-intercepts, especially if they go through nice points like this. I want to verify these algebraically, though. So I want to show you that these are actually the X and Y-intercepts of the equation. How do I show the X-intercepts? How do I find the X-intercepts? Algebraically.
You would
Well, what does it say here? Set the y value equal to what? So you're basically setting the function equal to 0, right? So we're going to take the function, which is x squared minus 4x minus 12, and set it equal to 0. How do I solve x squared minus 4x minus 12 equals 0? Okay, you would have to factor. Why are you going to factor it? It's an x squared term and you're setting something equal to 0. Do you understand that? How do I factor x squared minus 4x minus 12? Factors of 12 factors of negative 12 that add to negative 4. They are x minus 6 and x plus 2. Those equal 0. When I solve this, I get x is equal to what two values? X equals 6 and negative 2, which is what we got up here, right? There are x-intercepts. So algebraically, it works out as well. How do you find the y-intercept? So set your x is equal to 0 in this equation. So you're evaluating this function at f of 0 now. So it'll be 0 squared minus 4 times 0 minus 12, which is equal to just what? Negative 12, which is the point we already got 0, negative 12, right? Yeah, okay with that one. Everybody good with that? So let's look at the other parabola then. And I want you to look at the graph and visually give me the x and y intercepts. So it looks like one of them may be negative 3. Can we be sure it's negative 3 though? Why not? One reason we don't have a scale for that goes to that, right? Our scale goes by 2, so we can't be sure. What about this value over here? What is this? Oh, 2 point something, because it's 2 and something more, right? Looks like a little bit less than 3, a little bit bigger than 2. Could be 2.25, could be 2.5, could be 2 1/3. We don't really know, right? So what are we going to have to do to find these right here? If we can't find them from the graph, we're going to have to actually find them through the function, through the algebra, right? So that's what I want you to do right now. Find the x-intercepts for this equation. Give the x-intercepts for this equation through the algebra. Anybody getting the x-intercepts yet? What'd you get, Evelyn?
X equals 2.5 and x equals negative 3.
Everybody agree? Everybody else got those values? What'd y'all get?
I got x equals negative 3 and x equals 5/2.
That's 2.5. That's the same values. Yeah, that's the same values. It's cool. Anybody else get anything different? Anybody else get anything different? So if you didn't get anything different, I mean you got those exact values, right? So I can call on anybody right now, because you're about to do this problem. I can call on anybody right now, you can give me those exact same values. I know you can. I can call on anybody right now, and you give me the, Tristan, you can get them?
I got stuck on the factor.
I'm glad you honest with me, Tristan. Can anybody else be honest with me and tell me they got stuck on the factoring part? Thank you. I want to see hands come up. You can't factor, you can't do this problem. Y'all agree? So, when I factor, here's how I factor it. However you factor, keep your method, that's fine. Here's another method. I'm not as visually talented as some people to be able to see it. I really can't do that. That's not my strong suit. When I look at this, I do exactly what James did, except I go about it a little bit differently. I'm looking at, all right, over here. I'm looking at 2x squared plus x minus 15 is equal to 0. The first thing I do is I multiply 2 times negative 15 and get negative 30. I want factors of negative 30 that are going to add to that x, which are what? James, what did you say they were?
Negative 6 and 5.
Positive 6 and negative 5, right? Everybody understand that? So the next thing I do is this. I say, well, hey. Yeah, well, I look at this middle term. Because this is the part that's confusing to me, is the middle term part. I look at that middle term x. I'm going to take these two factors and rewrite it with, I'm going to take these two factors and rewrite the middle term just like this. 2x squared plus 6x minus 5x minus 15 is equal to 0. Yeah, see what I've done here? What is 6x minus 5x? It's still what? It's still x, right? It's still the x. Everybody understand that? Have not changed the problem any. I then do a process called grouping. Because I know when I see four terms, I need to group some factors together. So I split this in half just like this. And I look at just the left-hand side. What do they have in common? What else? The 2 and the x. So I factor out a 2x. When I factor out 2x, I'm left with x plus 3. I always bring the sign down, whatever it is. That's a minus. Then I look at the right-hand side. What do they have in common? 5. And I'm really factoring out a negative 5 here, so I'm going to change all the signs back here. So that's x plus 3. I'm always able to check myself. I always know I've done this right if these factors repeat. If they don't repeat, I've done something wrong. That's one way I like this. That's one reason I like this method, because you're always able to know if you did it right or not. So my factors are going to be the repeating factors, which are x plus 3. And then the ones that are outside together, I'll group those together. That's 2x minus 5. Which is the same thing y'all got. I'm just not as visually talented as I said earlier. I can't see it like you guys can see it. So if you can see it, great job. Your x-intercepts are going to be, first one is negative 3, 0, which it looks like from the graph it is negative 3, 0, right? The other one's going to be 5 half 0, which also looks like this from the graph. What is the y-intercept that it's going to be? If you plug in 0 for x, f of 0 is equal to 2 times 0 squared plus 0 minus 15. That equals negative 15. So you get 0, 15, right? So all you people said you can factor like that? Prove it to me again. Take your third graph. However you need to factor it, I want you to find the x-intercepts. Because again, we can tell that one x-intercept is what? We can tell that one x-intercept is going to be what? 0, 0. We can tell another x-intercept is going to be what? 0, 2. 2, 0, I'm sorry. The x-intercept we don't know for sure is this one next to it, right? I want you to find that x-intercept through your factoring methods. However you factor, make sure you can factor that, please. Thank you for reminding me. Yeah. Before you start this problem, what do they have in common? X. So what should you do first? Take out the x. Please factor out the x first. So these have an x in common. So when you start this process, you're going to actually do this. It's x times 3x squared minus 10x plus 8. You're going to factor inside of here now. Factor that out. Let's do this problem. Let's do it together. Let's look at it and try to factor it real quick. Three x squared minus 10x plus 8 is equal to 0. I want factors of 24 that add to negative 10. They are negative 4 and negative 6. So I have this. I'm going to write it like this. 3x squared. I always want to group something together, so I'm going to group 6 and 3 together. 3x squared minus 6x minus 4x plus 8. Split it in half. What do these have in common? 3x. I'm left with a x minus 2, right? Bring the minus down, so I'm dividing by a negative. What do these have in common? So all the signs are going to change back here, so it becomes positive x, negative 2. Repeating factors mean I did that, right? So my factors are 3x minus 4 and x minus 2. So it looks like my x-intercepts are going to be x is equal to 4/3 and 2. And then we had another one because we had x sitting up here by itself. That means x was equal to what there? 0. So there are your three x-intercepts. 0, 0, 2, 0, 4/3, 0, the last one. What is your y-intercept that is going to be? Where does it cross the y-axis at? Where does it cross the y-axis at? 0. If the x-intercept is 0, 0, guess what the y-intercept has to be? 0, 0. If it's this, then it has to be this. Can a graph cross the y-axis more than once? That is a question. Can a graph cross the y-axis more than once? If it's a function, that's the better question. No, it can't. Because then it won't pass the vertical line test, by the way. Alright. So here's what I want you to do. Hang on to this sheet.